Welcome. We're very glad you're here. My name's Mary Ann Rothman. I'm the Executive Director of the Council of New York Cooperatives and Condominiums, which has been around for some 45 years, providing information, education, and advocacy for housing cooperatives and condominiums in New York. Over the years, we've taken on a bigger and bigger advocacy role, and as more laws come down the pike, and we haven't neglected our education responsibilities, because tonight we will be helping you understand the new city mandated garage inspection laws. So let me tell you about our two excellent speakers from Rand Engineering and Architecture. And I suppose I should mention that Rand has always been a terrific friend to CNYC, and other Rand experts will be among the speakers at our 43rd annual housing conference in November. We encourage you all to register as soon as we launch that conference registration sometime next week. But I digress. Let me introduce Jimmy Vignola, who's Rand's structural team leader and director of technical design. He's a licensed professional engineer in both New York and New Jersey. He's a certified New York City inspector and a certified QRWI by the Department of Buildings, that a qualified retaining wall inspector. Jimmy also served on the board of directors of Structural Engineers Association of New York for 8 years and was president for 2 of those years. Jason Damiano is Rand's senior structural engineer. He's a licensed professional engineer in New York State, a certified New York City inspector, and a qualified parking structure inspector, which gives you a good idea of why he's one of our speakers tonight. He has a BS and an MS in engineering with a concentration in civil engineering from the Cooper Union, and has over 12 years experience with structural evaluation and rehabilitation work, specializing in garage inspection and garage repair program design and administration. Gentlemen, I'm going to turn this over to you.
Thank you, Mary Ann. Appreciate the intros and the chance to speak to you all tonight. Thanks for joining. I will get the presentation up here. Okay, thank you for joining us. So we will we'll launch into this. Jason and I are happy to be here from Rand. Been working on these parking structure inspections for most of this year, so we're happy, excited to share some of what we've learned with you. These are photos of us, our email addresses and contact info, so feel free to contact us after this presentation if you have any questions or if anything comes up at properties that you're involved with. A little bit about Rand. We're a full service firm. Lots of professionals. We do lots of different things. So let's get into tonight's topic. The New York City parking inspection program. It came out of this incident here in upstate New York. Usually for some type of legislation like this to be passed, this inspection program requirement. Unfortunately, the reality that we know as engineers is you usually need some sort of tragedy to precipitate, to push legislatures and government into doing things like this. So back in 2015, there was this collapse here in Johnson City, up near New York, near Binghamton in New York, and this incident prompted New York State to institute a law requiring that all parking structures were inspected every 3 years. So those inspections in New York State, roll down to New York City, and eventually New York City put their own law in place to also require the same thing. So the state inspection for any garages that are outside of New York City, those are also now required to be inspected by a qualified person on a regular basis. That went into gear in 2015, and all garages at that time in 2015 were required to have an initial inspection, and then every 3 years after that. So every garage in New York State should have had their initial inspection by 2021, and they have to maintain this permit to operate. There's some exceptions, 1 and 2 family houses, townhouses, and parking lots. The rules of the inspection program are very, very similar to New York City. We'll get into those. But one major difference between the city and the state is there's no state authority that we submit these reports to. They have to be submitted to the local authorities. So, you know, the village of Elmsford, or, you know, the city of New Rochelle. They might have different rules and, you know, regulations between the towns in New York State. I can't say we have experience with all of these agencies outside. There are many of them outside of the city, but we've done a handful of these inspections, Dobbs Ferry, Yonkers. So, you know, we're happy to help with those. But basically, the idea is the same as the city. At the end, we have to identify unsafe conditions. We have to identify and make recommendations for repair and maintenance. We have to give a time frame for those repairs. We have to assess risk and talk about the previous report and make sure that anything that was required by a previous report has been done at the time of the follow-up inspection of the second cycle. So very similar at the end to New York City. So the New York City program, we have begun referring to this, the New York City Periodic Inspection of Parking Structures, as PIPS. That moniker is kind of coming in. A lot of people are still calling it Local Law 126, but New York City DOB is now using this PIPS moniker, you know, similar to FISP, although, you know, this doesn't, they didn't put the program in this one, but, you know, more and more, I think you're going to start seeing PIPS, and it's definitely taking over in our office. So I mentioned the Local Law 126. Local Law 126, I know a lot of people are asking for a Local Law 126 inspection. Local Law 126 actually was the local law of New York City that instituted the entire 2022 New York City Construction Code. So it included the building code, the plumbing code, the mechanical code. Within the building code, there was a new article in the administrative, actually it was actually in the administrative code, this new article that instituted the parking inspection program. So 126 is a much more, you know, far-reaching local law than, you know, just referring to, you know, the parking inspection program. So DOB, you know, is bringing in this acronym, so we're adopting it. So what does the law affect? Which parking structures are affected? Essentially, all of them. If it's in a basement, it's included. Any type of standalone garage is definitely included. Doesn't matter if it's open or enclosed. You know, so a lot of these parking structures don't have exterior walls. They're kind of partially enclosed. All of that is included. So any building or a portion of building, such as a cellar, basement, that's used for parking motor vehicles, is included. So what's exempt? Auto body shops and auto repair shops are exempt. Garages with fewer than 3 cars are exempt, so 1 or 2. Parking lots, like the one you see pictured, are exempt. They do not need to be inspected, even if they have these mechanical lifts. that in a parking lot that is exempt. 1 or 2 family homes also exempt, as well as loading docks. We recently found out that loading docks are exempt from this, even if you have parking for 8 vehicles, that is exempt. So the deadlines for this first cycle is shown here. The bright red, lower Manhattan and the Upper West Side is due by the end of this year. So we're getting down to it, 5+ months to get in all of these initial cycle 1A reports for all of the parking structures in that bright red area. Cycle 1B will start January 1st of 2024. You get 2 years. Brooklyn and basically the rest of Manhattan will be cycle 1B. So there'll be plenty of work there. Cycle 1C is the years 2026 through 2027. That's the rest of the city, Brooklyn, Queens, and Staten Island. Cycle 2 will start up again then in 2028. So 5 years from now, 6 years from now, we'll be into cycle 2A, and we'll be revisiting all of the parking structures that we're initially inspecting right now. If there is new construction in these areas, we always get the question, do I need to file? You need to file. All parking structures need to have an initial inspection within 6 years of their initial TCO or CO. So if you have a new construction and that 6-year window falls within the filing window associated with the location, you do need to file. A lot of these new constructions are, if that 6-year date falls beyond your window, you don't need to file. So basically, you need a TCO, initial TCO for a initial filing in the lower Manhattan area. It would have to be in 2017 or earlier for you to need to be able to be required. So it gets a little tricky there, but if you have a question, you can feel free to contact us and we will help you sort your way through it. But the key is the date of the first CO or TCO, and then 6 years from then, are you in the filing window or not? If you pass it, then you'll file cycle 2. Some of the rules and regulations, right? This is the rules of the city of New York is the place where most of these things reside. What the inspection program requires and the report. So every 6 years, right? The most important thing is that the person doing the inspection is a qualified parking structure inspector. We call them QPSI. Jason is one. So this is the key. Even if you didn't want to, come to RAND, please make sure that whoever you were talking to is a QPSI. That is the most important thing. The DOB vets us when we apply to be a QPSI. You need to have 3 years of experience with parking structures specifically. You need to submit your resume. You need to give them a list of drawings, a list of projects that you've worked on, and then there is an interview with multiple people from the DOB. They grill us about our experience and what would you do in this situation. So it's something that you have to work for to actually get this qualification. So make sure whoever you are talking to is a QPSI. If not, the report's going to get rejected and it won't be worthwhile. So the QPSI must put together this condition assessment report. The bottom line of the condition assessment report is that we classify each parking structure as safe or unsafe, or the middle category, which is where we normally wind up, is safe with repair and or engineering monitoring, SHREM. This is very similar to SHWARMP if you're familiar with the FISP program, which most condos in Manhattan, New York City are. So a lot of similarities with the FISP program. I'll refer to it a lot, but this is the bottom line that we're looking for in this condition assessment report. So as part of the inspection, we have to review previous documents, previous reports, PIPS reports. Right now there are none, but in cycle 2, we'll be checking the cycle 1 reports. We also have to look at any structural drawings. We check violations, and we are supposed to review FISP reports where the facade is part of the PIPS report. So what does that mean? The facade of the structure may or may not have to be included in the PIPS inspection. It needs to be included in the PIPS inspection if the parking takes up more than 50% of the building. So your typical Manhattan parking garage that's in the basement of a 12-story building does not need to include facade inspection, right? Your building is in FISP, you can basically exclude that part of it. If there is a standalone garage, whether it's 2 stories or 4 stories or 6 stories, I don't know, we haven't run into any of those parking structures that tall, but a standalone parking structure building, we need to inspect the facade as well as the interior. So we have to develop this condition assessment program. It needs to be specific for the structure, right? This is the no walk, no drive-by inspection rule from FISP, right? We need to actually go there, and we need to consider the materials and the condition and the age of the building and the performance of the building, and decide how to assess this building. Is it well maintained? Is it not? What do we need to do? Do we need to do, if we get into this more, we have to, review all aspects, all details, and the appurtenances. So we have this visual, right? The initial, the process starts with a visual inspection. We'll have somebody walk through the building. This is when we're gathering information about materials, conditions, performance, as I mentioned. It's really important that you have somebody that's experienced in structural assessment, go out there, walk through, and then it is required that part of the inspection include physical examination of at least 10% of each type of structural element. So 10% of beams, 10% of slabs, 10% of columns need to be physically examined in some way, shape, or form. So physical examination can be pretty simple. It can just be sounding. You see here in this photo, our office, we have these tools, we invested in these tools, they're kind of like little rollers, and we can go out during the visual walkthrough and we can sound columns, we can sound overhead slabs, we can sound floor slabs, and get that counts as physical examination. So if you have a garage that's in very, very good condition, you might only need sounding in order to meet this requirement. If there are more severe deterioration, you might need probes. We might need to do some GPR scanning, might, at the high end, like need some cores, for testing. So the physical examination really could be, really there's a big range of what that can mean, from really simple, you might not even realize we're doing it if everything is in good condition, to, really being, very, very intense, needing, contractors and testing labs. After doing all of the physical examination, we have to do some structural analysis, get, some things, determine what our recommendations are, what needs to be repaired. There's a final inspection. The final inspection needs to be done by the QPSI. The initial inspection does not need to be done by the QPSI necessarily. So that's okay to do. But basically, once we kind of have an idea, get that initial check, do some physical examination. We'll have our QPSI, Jason, visit the site, do the final inspection, make sure everything is matching up, and take the next step. And that would be writing the report, right? So now we have to write our report. The report requirements are pretty specific. They're right out of the code. We need to describe the structure, the gravity, and the lateral load resisting systems. We need to do a structural stability analysis of the typical and the worst case conditions. So those are a little bit different than the FISP program. If you're used to FISP, this actually, the PIPS program actually requires that we do structural analysis. DOB wants to see our calculations. So if you have drawings that show us the structure, that helps a lot. We've been in we might have to, in some cases, actually ask for probes just to expose the structure so that we can do the structural analysis to prove to DOB that the structural stability is intact. That also can be very challenging when there's a lot of deterioration, right? Sometimes our analysis, it might show that you need shoring and that you need temporary protection, right? If we encounter a lot of bad conditions and the analysis says the structure is not stable, that's going to be an unsafe, and we're going to have to work on that right away. So that's a little bit different. What's also a little bit different, we have to include floor plans with this report. Plans showing both where we performed our physical examination, and then a second set of plans showing where the SHREM conditions are. We also need to discuss within the body of the report the existing conditions and give itemized recommendations for repair, including the specific timeframes. So again, that's similar to the FISP, where we'll say patch and repair spalled concrete, needs to be completed within 2 years, right? We have to give dates. We're not allowed to say within 2 years, but we give you timeframes. Sometimes it might be 6 years, right? If we think it's okay, this can stay till the next cycle. We also need to include photographs of representative conditions, including safe, right? We need to give them a full kind of catalog of photos of all different types of structural elements and appurtenances, including the safe ones. This is what the floor plans look like that we are submitting. This is basically a map of where we did these 10% physical examinations. And then these would be, the second set. This is actually showing the SHREM conditions. There's crack here, spalled concrete in other locations. Active water leaks, things like that, right? So, it does take some time to prepare these drawings, does take some time to prepare the reports, the photos. If you have a proposal for a $2,000, PIPS, they're probably underestimating how much work it's going to take them. There's work involved. If you have drawings, any kind of drawings, of course, is going to help the QPSI, kind of get this thing going. I mentioned it a couple times. Appurtenances are also part of the inspection program. We need to look at all of these things: lighting fixtures, bollards, vehicle guards, attendant toll booths, looking for unsafe conditions or repairs that need to be made. There are a few things that are excluded, including the roll-up gates, and elevators. But, really we really have to look at, everything that's part of the parking structure. Another new part of this is we need to develop and submit an annual observation checklist for your specific garage, right? So we develop this checklist. You see a sample here on the side, which then the owner, the garage, is responsible to use this checklist to perform annual inspection in between the PIPS inspection, right? So you should have 5 of these annual inspections using this checklist, and then the 6th year, you'll do a PIPS with a QPSI. So we developed this, it's part of the report, but you are responsible to make sure that this is done annually. Rand, happy to help out our clients we would do these if you want to engage us to do that. It is not required to be by us. It can be by the building super, someone knowledgeable that you trust to be able to do this, but you must use the checklist, and you must have these checklists on site in case the DOB shows up. That is a requirement, right? DOB can ask for these anytime. You're supposed to have them on site, and then we need to include them in cycle 2, the filled out completed checklists. So what are the filing classifications? Not too hard to figure out. You've got safe ones, everything is okay. There's not so many of those. You have unsafe, where there are hazards that are presenting an imminent danger to people or properties that need to be repaired right away. And then you have the middle ground, where there are things that need to be repaired so that they do not become unsafe, right? DOB's criteria for SHREM is that it is a condition that needs to be repaired in the next 6 years to prevent it from becoming unsafe. So, there's some judgment to that. But essentially, really any sort of loose overhanging material is going to need to be addressed right away. That would be considered unsafe. We'll get into more of those details. Also, again, similar to FISP, something that is SHREM needs to be repaired before the next cycle inspection. If not, it just automatically becomes unsafe. So, we try to take that into consideration when we're, figuring out what is SHREM and kind of like what we can kind of get by with as calling it safe, because those are the only options. Unsafe conditions, like I said, need to be fixed right away. We're supposed to notify DOB of an unsafe condition, and you are supposed to initiate repairs right away. The unsafe conditions are supposed to be addressed within 90 days. You can get extensions for those 90 days. The QPSI must apply for those extensions as well. And then once all of the unsafe conditions are addressed, they have at least been brought to SHREM, if not safe. The unsafe report needs to be amended by the QPSI. So, a new filing. There are various timeframes involved that we have to meet, but we can always get extensions. The amended report is the one that really is critical, because that is the category that takes an unsafe to a SHREM or a safe. Nobody wants an unsafe hanging around. In fact, you have to change it. You're not allowed to leave it unsafe. Your subsequent report you can change to safe from SHREM. Sometimes it's not really worth it, or we make other modifications like changing the time frame. So if we want to revise a report, that's called a subsequent report. All the reports as of April 17th of this year need to be submitted via DOB now. Again, I think most people that are managing properties, owning properties, working in construction in the city at this point, somewhat familiar with DOB now. But, this does require owners to go into the DOB system and sign things and pay fees, similar to FISP or any other alterations, repair projects that, you might be doing. There are fees for filing, $305 for an initial fee. And again, that's, for an amended or a subsequent filing, there is a fee. So that's kind of why I was saying, sometimes people don't really want to do the subsequent filings because, they'll save the $85. There are penalties with this program, just like everything else, right? Late filings, failure to files, failure to correct unsafe conditions, you will get violations, and the violations can add up if you don't, act on them. So of course, when we're working with you, we try to avoid the civil penalties. but they are out there. If you get a penalty and you don't think you deserve a penalty, you can challenge it. You do need a QPSI to do that, to challenge that on your behalf. That's kind of the outline of the program. What goes into it, the administrative side of it. Going to turn it over to Jason. Jason will talk about really what he's seeing in the field, things that he's running into, both in the conditions and actually with the approval process. We've gotten a handful of the inspection reports accepted at DOB now. So, we do have experience and understand better what the DOB is looking for from our reports. So I will turn it over, but before turning it over to Jason, I think we have one question in Q&A, Marianne.
Yes, we do. The questioner has asked, is there a list of contractors approved by the city to do the repairs if needs be?
I haven't seen a list of that. I think any contractor is qualified to do it. Just general, as long as they're a licensed New York City contractor, they would be acceptable. So there's no further qualifications required on the contractor end for these jobs.
Jason, as our QPSI, will you be talking a little bit about contractors and bidding and maybe getting sources of contractors?
Not specifically, but pretty much any PE who works in this space is going to be able to get a list of contractors that are working.
So now we can let you proceed with your half of the presentation.
Yes. All right, thank you. Yeah, as Jimmy mentioned, I'm going to get into more specific things that we've seen in the field. First, I'm going to start with some common problems that we see in parking structures. Most parking structures are concrete or at least have concrete slabs in them. The number one thing that we see that is causing problems in these garages is water and de-icing salts that are brought in by vehicles. Water can be brought in year round, but specifically in the winter, there's de-icing salts mixed into snow and ice and rain that is brought into the garages that if there's no protection of the slab that gets into the slab, it causes deterioration of the concrete itself, of the steel inside the concrete, and that problem just gets worse and worse over time. There are also external sources of water, like subgrade through foundation walls, groundwater conditions. A lot of parking structures are subgrade structures, meaning they're underground, and some of them are built even below the groundwater table. And a lot of them are also built below plazas and terraces. So that's just another point of access for water to get through if those are not properly maintained or not properly waterproof. Another issue that we see within the garages themselves is ponding of water and poor drainage and lack of waterproofing. So a lot of garages have drains in them, but as we'll see on the following slides, if there is not waterproofing and if the water is not able to get to the drains, you end up in a situation where the water is just getting into the slab, even though the intent is for water to go to the drains. There's also a lot of previous repairs in these spaces. Garages need maintenance over time. It's a very common issue, but those are often weak points for future repairs. And these types of issues can cause damage to other building systems, like mechanical systems that may be electrical systems that are going through the garage, and they can also be damaged by other systems. If there's a leaking pipe or something, that can also bring water into the space. You can have situations where there's just high moisture in the air because of some adjacent mechanical space. So this is a pretty typical concrete garage structure, and as you can see, there's deterioration that is concentrated right at the wheel wells, right where all the water drips off the car. It gets onto the concrete slab, and in this particular garage, there is no traffic coating. You can see a drain there in the picture on the left. The issue is once the concrete starts to deteriorate, the water is never going to make it off the cars and into the drain because it's just going to go down into the cracks, which eventually become concrete spalls. So even though this might look like a pretty typical garage condition that might not be at first glance a major concern, this slab serves two structural purposes. It is there to support the cars themselves, the load that they impose on the slab and transfer into the columns, but it is also, this slab is providing bracing for those columns. The columns you can see in the photo on both the left and the right are building columns. So they go up another, I think in this case, 25 or 30 stories. And you can have situations where you have a localized failure, which just means, you know, that slab is deteriorated to the point that it fails, but it can actually cause a major issue for the superstructure because the slab is bracing the column. And if you have an unbraced column, you have a situation that can lead to a larger structural failure. And that's one of the things that we want to emphasize with this program, is that DOB is making sure it's, you know, professional trained eyes that are getting on these, getting in these buildings and making assessments, because there's, you know, at first glance, this might look like a simple issue, but getting a professional in there, making sure they can tell the difference between the type of spalling, the type of cracks, and the worst case scenario is very important. And you know, here's some more common problems. This is a terrace space on the left that's over a garage. The terrace space has not been maintained. The drain has not been maintained. So any water that gets into this slab is going straight into the garage below. And then on the right, you see a situation where there's a through wall leak. That's a below grade structure with a concrete foundation wall. The water is getting right through the foundation wall, which deteriorates that wall, but also can deteriorate the slab within where the cars are driving. So you have kind of, you know, two issues with that that, you know, need to be repaired and are not necessarily related to water being brought in by cars. Another thing that we see commonly is these type of quick fixes that are often performed by building staff. In the photo on the left, that's a drip pan. We see them everywhere. This is a situation where there's water dripping through a slab from a terrace above. And, you know, whoever was parking the cars underneath didn't want the water dripping on the car. So they put in a drip pan and, you know, problem solved. The issue is it doesn't address the source of the problem, you know, which is water infiltration. So the water is able to continue getting in the slab, and over time it continues to deteriorate the concrete structure. But unfortunately, if there's no engineer that's brought in to take a look, you're in a situation where this will just continue to deteriorate over time. The second photo on the right is a photo of an area that, you know, again, building staff attempted to put a coating on, you know, a waterproof coating. Unfortunately, if you put that on a ceiling, once water gets in the slab from above, it's going to make it to the bottom of the slab, and then it's actually going to be trapped in place by that coating that was just placed. So now you have a situation where the water is stuck in place and it is actually accelerating deterioration of the slab. So these are two things we commonly see in almost every parking garage we go into that has some level of deterioration, but unfortunately these are generally bad signs and even accelerants of damage. These are two situations where you have mechanical systems on the left, you know, an HVAC system, and on the right, some piping and plumbing. So on the left, that's a situation where, you know, lack of maintenance led to, you know, HVAC ductwork being destroyed to the point that it will need to be replaced. This is something that DOB is requiring us to look at, you know, if there's a hazard, if something on that is loose or, you know, ready to fall off, that is a hazard to people. And then on the right is a situation where, you know, localized plumbing system, there's a mechanical room above this space, is actually causing damage to the slab. So that's the ceiling of a parking garage, but it is being damaged by the systems that are in place. And then similar to the mechanical systems and plumbing systems we just went through, there's also electrical work in, you know, every garage. There's lighting at minimum in every garage we go into. So in the photo on the left, that's a conduit that's embedded inside of a concrete slab. Unfortunately, that's not the best design because once water can get in to that conduit through a crack anywhere in the slab or along the line of the conduit, it's not only going to deteriorate the conduit, but it can travel within the slab and come out at a different location, causing a much larger, you know, spall area than you want to deal with. It's also dangerous for contractors. You know, that could look like deteriorated rebar when in reality it's a live electrical line. And then on the right, you see a typical surface mounted conduit where the water is getting through the slab and the conduit is deteriorating to the point that it also needs to be replaced. and obviously the slab surrounding it is also in bad condition. So to get into more specific, technical problems that we see in concrete slabs themselves, pretty much all the problems that we see in concrete start with cracks. Concrete naturally cracks. It is a normal thing to see cracks in concrete. Unfortunately, if there's no protection of that concrete, water is able to get into the cracks, and once it makes it to the rebar, it will start to deteriorate that steel. Once the steel deteriorates, it starts to expand, and the concrete goes through a process that's called spalling. So the concrete will actually spall off of the rebar, meaning it separates as the rebar expands, and the concrete cover on the slab or beam or whatever it is will be lost. So it's definitely the most common thing that we are seeing in terms of deterioration, and this also common issue is the lack of joints. A lot of times joints are not either in the slab or not properly detailed, and it's just another thing that causes cracks and allows water to get into the structure. And here I'm going to kind of walk through the life cycle of a typical crack in a concrete structure. So on the left, you see in the middle of that slab, there is a pretty early stage crack. So the crack exists, there is water getting through. You see some evidence of water infiltration, but at this point, it's likely just a crack repair and some repairs from above. As a crack is allowed to further deteriorate and allow more water, and it starts to spall. You can see on the right, there's some rusting, deterioration of the steel or steel reinforcing within the slab. That starts to cause the concrete to spall, which means your repair is larger, your repair is more expensive. And, eventually it starts to get to the point where it can cause structural stability issues. In the next slide here on the left, you have a situation where not only was a crack attempted to be repaired. You can see the kind of the line of epoxy from left to right. That was an attempt to seal a crack. Unfortunately, they didn't address the source of the water infiltration. So when that happened, they attempted to do a spall repair, which is that gray box in the middle. That didn't work either because, again, it doesn't appear that they addressed the source of the water infiltration. So now you have a situation where even a larger area is spalling. So now you're stuck with a larger repair and a more expensive repair, and potentially a situation where the structure needs some sort of reinforcing or replacement because it has deteriorated past its capabilities. And then on the right, you see kind of the full life cycle of a crack. On the top of the photo, you see kind of the hairline minor crack that hasn't started spalling. Then as you get to the middle of the photo, the concrete starts to spall. And then towards the end of the photo, you can see the exposed rebar. The concrete spalls have been removed or just fallen off. And it's at the point where it likely needs a structural repair. This is more common problems in concrete. This is a top of slab issue. So we saw what happens when water is able to get through cracks and get to the bottom. On top here, you can see on the left, that's just a basic crack, but it allows water to get in. And as water can get in, it can do the same spalling process as we saw from below, but on top. And you see on the right photo, that's a concrete slab that is spalling. It always looks a little bit different because the cars are driving on the surface and gravity doesn't pull the spalls off. So you kind of get this, gravel and, loose material. It causes tripping hazards, which are also, an issue and something that we're looking for in these inspections. But, either side of the concrete if it's not protected, it's going to, deteriorate in this way. Another common building material we see in these garages is steel. So in the photo on the left, that is a steel beam that is below the slab that is framing out of that column. And the top flange of the beam is deteriorating because, water has gotten to it. And you can see that effect on, the concrete and the traffic coating. They're deteriorating at a pretty rapid rate there. But steel, same as steel in concrete, steel beams, any larger steel framing needs to be protected in the same way. And you can see in the photo on the right, that is a steel beam that's encased in concrete. the concrete is cracking and spalling off because some amount of moisture has gotten to that steel beam, that is a situation where we need to remove that concrete, see what condition the beam is in, possibly reinforce the beam, and then repair the concrete encasement. Next, these are steel columns. The one on the left is encased in concrete, and the one on the right is encased in masonry. So on the left, pretty typical concrete spall that we've seen throughout. As steel deteriorates, it expands. So in both photos, it causes the encasement to crack. The encasement can get in pretty bad shape, but usually if the encasement's at the point where you're seeing major issues, your steel is likely pretty deteriorated. So it can actually cover up some of the issues, but this is an early sign that you have, water infiltration getting to that column and that it needs to be addressed. And then here you can see this is after the encasement gets removed. You can see severely deteriorated steel columns. The adjacent beams don't look as bad. They were left, exposed, but the columns, you can see through the one on the left, the one on the right is also severely deteriorated. It's a situation where, no one could see what was wrong. There was probably some spalled or cracked encasement, but once you remove the encasement, you really see how bad it can get, and it certainly needed, shoring and structural repairs in order to fix up this area. So I'm going to go through a couple of examples based on, feedback we've gotten from DOB. In this case, we found a deteriorated condition and we're trying to determine whether or not it is SREM, which is safe with repairs, or if it needs to be filed as unsafe. So in this set of photos here, we originally tried to submit the photo on the left to DOB as a SREM condition, meaning we said, this needs to be repaired. We acknowledge that, but we don't feel it is unsafe. They rejected that, saying they feel that there was loose material in the photo and that we need to take a closer look. So we had a contractor come out, remove the loose material, and got us access to the rebar so we could take some measurements. As Jimmy mentioned earlier, we have to provide a stability analysis for SREM conditions. So we had to measure the rebar in the photo on the right, see how much section it had lost, and provide DOB a calculation stating that even though this slab and this beam have deteriorated, they can still handle the loads they were designed for. So, for example, if rebar has lost 80%, has lost 20% of its section, but it can still handle the loads that it was designed for, that's fine. But if rebar has lost 80% of its section, and we can't prove via calculation that that area can handle the loads, it is actually going to be an unsafe condition. Next is another example of a situation where there isn't any loose material. The loose material has already been removed, so we don't have to go through that hurdle, but now we're in a situation where we have to assess the structure itself. So in this case, it's our job to, same thing, measure the rebar and determine whether or not this slab can handle the loads it was designed for in its deteriorated state. So in this case, all the rebar is exposed, but there may be situations where we only have access to one bar. Those are the types of situations where we might actually need to do a probe to check, how the reinforcing is in other areas, what size it is, stuff like that. This is another situation where structural drawings are really helpful because we can, make a quicker assessment and be able to determine whether or not this is SREM or unsafe, and we're allowed to, jump over that bar that DOB, makes us meet to qualify something as SREM. And then here is another questionable condition, though it was pretty clear when we walked in here that this was actually an unsafe condition. So the rebar that are going up and down in the photo, that's mostly just staining in the concrete. The rebar had deteriorated to the point that it didn't really exist anymore. And then you can see the long bar that's going from left to right gets really thin over towards the right. So even though, this is a situation where, it hadn't collapsed on its own or anything like that, but at the same time, we could never submit a calculation to DOB that would show that this could pass the stability analysis. So this is going to be an unsafe condition. We need to file it accordingly. So I'm going to pass it back over to Jimmy. I believe someone has their hand raised. I don't know if we want to.
Yes, it's
something with that.
Elena's hand is raised.
Elena, did you have a question you wanted to ask?
I can, Elena, I have,
Yes,
can-
no, I don't have a question. Thank you.
oh, okay. Hopefully we answered it.
Yes.
So we have a little bit more in our presentation. Just wanted to talk about the entry collapse, right? I mean, this actually happened after the local law was enacted, but of course it drew a lot of attention. When this happened, in April, someone died. A lot of people, were injured. Several people were injured. Property loss. No one also significant, right? So initially, when this happened, as whenever there is a collapse, we get flooded with calls. People are very, very concerned. I want you to come. I want you to check my structure. I'm afraid it's going to collapse. There'll be an investigation of this, but we know several of the factors that went into this collapse, right? And whether it's this collapse or it's the Surfside collapse in Florida a few years ago, the ingredients of these collapses are usually the same. And one of them is lack of maintenance, right? There have been violations. People knew about cracks in this structure, and they weren't addressed. Again, that's I think a part of the reason we really want to stress, like, make sure you have somebody that is experienced with concrete repair doing this. There's a lot of structural engineers out there. I work with a lot of them. I have a lot of respect for structural engineers. Someone who is designing railings, it probably doesn't know enough about concrete to assess this, right? So all concrete cracks, it is in fact required for your concrete to crack. Show me concrete that's not cracked, and I will tell you it's not really concrete. All concrete, it shrinks. The majority of concrete cracking happens within the first 48 hours of concrete being installed, right? So 48 hours, so sometimes we get called for concrete cracks and it's like, hey, this thing cracked 70 years ago and it's fine. We're not concerned about this crack. In other cases, we might be like, put in shoring right now, evacuate the building. So you need to have experience with that. This failure, this was a shear failure, right? The slab broke in shear, right? It was overloaded. The strength, the inherent strength was, compromised because of deterioration, lack of maintenance. And eventually the concrete itself just split in half as a shear failure. Shear failures in concrete are catastrophic. It's a brittle failure. Any significant failure is via shear. I mean, maybe I'm exaggerating slightly, but what I mean is if you look in this picture, you can even see some of the rebar kind of hanging in the air. That's really common. I look at a lot of these things, look at, earthquake, collapses in earthquakes. Many times, you'll see rebar, it's intact rebar, it's hanging out. The rebar, the bending, flexural strength usually is not what causes collapse. Even though we went very in depth on loss of area of rebar, it is important, but it often isn't the most important thing when it comes to structural stability. The real problem comes when you lose meat, the actual cross section of concrete, right? When if you think back at that first photo, Jason was talking about bracing of the columns, where actual, like, the spalls were coming out. That's really where there can be danger. So if there's a situation, a real imminent safety, whether it's PIPs, garage, or any kind of concrete structure, if you need a structural assessment, it's really important that whoever is looking at it really understands concrete specifically, how it works, you know, what is really the danger, and what is not. You know, I'm a structural engineer. Yeah, I have junior engineers work for me. You know, we're so used to steel, right? I get young guys and ladies coming out of school, you know, they design steel beams, and you know, they give me their steel check, and they checked the bending, and they checked deflection, and I say, thank you very much. This is a concrete beam, go check the shear, because the shear is what's going to collapse this, you know, not the bending. You know, so, you know, I really emphasize that with engineers, you know, understanding how critical it is. Like, it's just essentially there's too much weight put on these structures, and concrete can literally split. So that's what happened to Dan Street. You know, pretty certain that's what they'll be saying when the final forensics comes out. And how did we get there, right? You know, the building lasted for 100 years, right? Built in 1928. So it took 98 years for this to happen. And there were certainly warning signs along the way. So one of them, again, lack of maintenance. We know that this building had at least like 25 years of documented damage that wasn't corrected. So you have to maintain concrete structures. Concrete structures are not some sort of like superstructure that is never going to deteriorate or you don't have to pay attention to. It needs to be maintained, and small problems become big problems. The other thing here was the overloading of this structure, right? It was way too many cars for what it was designed for. They put in mechanical lifts, which were not allowed. So if you didn't know, your C of O for a garage tells you how many cars are allowed to be parked there. The C of O lists if mechanical lifts are allowed. DOB is looking for that. We are looking for that, especially now. If we go into a garage, even for a, you know, courtesy visit, if it is overloaded, we're saying, hey, CFO says you need 34 cars. You got 160 in here. You need to remove those right away. You know, it's unsafe. You know, DOB is going to shut you down. So, you know, be aware of that. It's on the CFO, and even more so than, you know, the violations that could come or getting shut down. It is a real safety hazard. You know, collapses and structural failures, thank goodness, they're really rare, right? When a building goes down, it's news, right? You know, that Surfside collapse, that was worldwide news. It's very rare, but we know how they happen. And, you know, there's always an element of lack of repair, lack of attention, lack of maintenance. And there's very often an element of overloading these structures, of somebody coming in and asking the structure to do something that it wasn't intended to do. So, you know, we're on the lookout for these. You know, those are things that you should also look out for if you're worried about the safety of something. You know, you might see a crack here or there. Maybe those things aren't cause for concern. But if you know that nothing has been repaired in that structure for 40 years, you know, now that you can get more concerned, you know. So, you know, we want to address those. And then, you know, we know that out of that, you know, DOB obviously reacted, and, you know, they headed out. Or Jason, you want to jump in here, take us to the end?
Yeah. Yeah, as Jimmy mentioned, DOB has been going around to many garages, been issuing violations. It's been a constant theme since you know, the tragedy down on Ann Street, and you know, it's just something to be aware of. You know, they haven't been closing every garage. You know, there's different remedies for each violation, but we're certainly seeing an uptick in focus on this issue. So then the final thing we're getting into, just like 3 quick slides here on prevention and maintenance. You know, we talked about all the things that can go wrong with concrete. We talked about, you know, the main issue is water. getting into the garage, mostly brought in by vehicles. We're just going to go through quickly, recommended repairs and what to do about it. So this chart is a chart commonly used in the industry to show, different options for repairs. You see there's lines A, B, and C. Line C, the top one, is the one where they wait as long as possible to do a repair program. The repair costs more. They have to do it more frequently. And, it ends up costing significantly more money. And that's, you can also see in this chart, deterioration accelerates over time. So once your structure starts to get in bad shape, it will just get worse and worse and worse at a faster pace if you don't address it. So C is, waiting as long as you can to the start of, major structural failures. B is start of minor localized failures, where you don't have to repair quite as frequently. It doesn't cost quite as much, but it's still, a repetitive issue. Normal wear A would be essentially just, correcting waterproofing. Just maintaining that, which is what we recommend for every garage. If you can do preventative maintenance, you will spend the least and have to do it the least frequently over time. And then, final slide here. I'm just going to go through the best practices. As we said, you need to implement a routine inspection program. We'll give you the checklist that, someone qualified has to step in and perform. Be proactive. Like we said, when there's a crack and water is able to get into it, instead of getting to the drain, it's just going to get worse. It's going to cause spalls. It's going to cause, larger areas to be addressed, need to be addressed. And then, the leaks themselves, if there are leaks coming, through a slab due to cars bringing in moisture or, anywhere else in the garage, it should be addressed as soon as possible before they start doing damage. And then the number one thing, once you finish a repair program, is to make sure you install a traffic coating system. It is a waterproofing system that can be placed throughout, any garage. It will protect the slab. It will prevent water from getting to the concrete. It will go, off the cars onto the coating and into the drains. So if you're able to do that at the end of a major repair program, a lot of buildings are going to be doing major repair programs over the next few years. If you can finish that by getting the traffic coating in, then hopefully next time you're just doing minor repairs to a traffic coating. And then, the final thing, just keeping track of drainage and making sure your drainage system is okay. A lot of drainage systems, especially if they haven't been able to be maintained, are in pretty bad shape and can cause ponding and other issues. And, just make staff and management aware of, the issues and what to look for, and just know if they have a question, bring in an engineer. That's the most important thing to prevent a worst case scenario. And that wraps it up for us. I don't know if there's any additional questions.
I think we've all learned an enormous amount, and that we're a little bit speechless in the question department, but this was terrific. Thank you so much. And I'll remind people that we will distribute these slides to everyone who is here tomorrow in the morning. Thanks so much, guys. And thank you everyone for taking part in this wonderful class.